Power is a concept that we have learned quite a bit about over the course of this year. We know power as being the rate at which work is done, or another way of explaining that is the rate at which energy is transferred from one object to another. In electrical circuits, often that energy that's transferred comes from electrical energy, or electric potential energy, and gets transformed into thermal energy that is released either as heat or sometimes as light. We can calculate the amount of power that an object has, or sometimes we call that the energy dissipated, the same way that we always have, by saying power is work over time. But when we're dealing with electrical circuits, there's another equation we can use that is often more useful. This equation says that power is current times the potential difference, or voltage. Sometimes we lose that delta in front of the V, so we write P equals IV. That's still voltage or potential difference, even though it doesn't have the delta in front of it. Now, we've also learned about Ohm's law. Ohm's law says V equals IR. So we could take this equation for power, P equals IV, and use substitution to transform that into two other forms. One way would be substituting in for V. So we say P equals I times R, or in other words, P equals I squared times R. The other way that we could transform this equation would be solving Ohm's law for current. So current is voltage divided by resistance, and plugging that into our equation. So P equals V over R times V, or P equals V squared over R. The equation that's boxed, P equals IV, is the one that's on your equation sheet. However, the other two forms may be more useful as we look at various example problems. Let's take a look. In this example, we're talking about a hairdryer that I use in the morning. It has a power rating of 1,850 watts, and outlets in the U.S. supply a voltage of 120 volts. We're asked to find the internal resistance of this hairdryer. So we can start off with equations that are on our equation sheet, primarily P equals IV and V equals IR. And as I just mentioned, we can combine these two equations to get an expression for power that is in terms of the two things we're given, or the thing that we're looking for, really. Two things we're given and what we're looking for. So we're given power, we're given voltage, and we're asked to find resistance. In other words, I want an equation that does not have current in it. So where current appears in the power equation, I'm going to substitute in voltage over resistance so that I find that power is equal to, it should have been voltage over resistance times voltage. So power is V squared over R. That means that R is equal to V squared over P. When I plug in my values that are given to me in the problem, mainly 120 volts, and I square that, divided by 1,850 watts, I can find the internal resistance of my hairdryer. That internal resistance ends up being 7.78 ohms. You could also do this problem by plugging in what's given to us into the power equation, so that I would first calculate current, and then I could plug that current and the voltage into Ohm's law and find resistance. So I could do this in one step by combining the equations, or I could do this problem in two steps. Either is totally acceptable. Let's take a look at one other real-world problem that comes about with power. In Cincinnati, Duke Energy charges approximately 14.2 cents per kilowatt hour for electricity. That includes all the generation fees, which are just fees that are added to your bill for having to create that power. We're going to calculate the cost of various things. These are 3 things that you might experience at your house. Things like leaving on a 60-watt light bulb for 24 hours. Maybe that's something that your parents yell at you for leaving the lights on. Cooking a turkey, maybe on Thanksgiving Day for 4 hours. Or binge watching a season of Friends on Netflix, which is about 9 hours to watch a whole season. We're going to do one of these together, and then your task is going to be to do the other 2 on your own. So let's start with doing part A. Now, there's no exact equation for this, but I'm going to look at what's given to me. I'm told the cost of energy is 14.2 cents per kilowatt hour. Okay, so kilowatt hour, that means kilowatts times hours. And I'm trying to find out the cost of something. Now, we usually do things in dollars, not in cents. So I'm going to convert that to say $0.142 per kilowatts times hours. And in the end goal, I want to get something that's in dollars. So first of all, I need to get rid of the kilowatts that's in the denominator. And it says that I have a 60-watt light bulb. So I'm going to convert that into kilowatts. And I would have 0.06 kilowatts. So if I multiply my cost, the $0.142 per kilowatt hour, times 0.06 kilowatts, the kilowatts unit would cancel out. Put that over 1. But I still have this pesky hours in the denominator here. Since it's in the denominator, I want to multiply by the number of hours that I'm using this device, which is 24 hours. So I have 24 in the denominator here. $24 in the numerator there. Those units cancel out. I'm left with units of dollars, which is what I wanted. So then I go through and I multiply all this out on my calculator. And I find that it would cost approximately 20 cents. That's not too bad. And that's using one of those old non-energy efficient bulbs. A whole whopping 20 cents to leave it on for a whole day. Your task now is to calculate how much it would cost to cook a turkey, as well as to binge watch a season of Friends. Make sure that you write out your work and your answers for those 2 parts.